So for problem number 32, here's the situation. We've got this red vector here that's 40 degrees from the positive x-axis, and the length of this vector is 60 newtons. It's a 60 Newton force, actually, represented by the vector. And then we have this blue vector that represents a 70 Newton force that's being applied to the same place right there at the origin. And it tells us that the 70 Newton vector is being applied at an angle of 130 degrees. And so instead of kind of cluttering up the diagram here, instead of writing 130 degrees, I'll do it on the back side right over here, and let this be 50 degrees from the horizontal. Okay, so just took the 180 minus 130. Okay, so anyway, we're going to take this vector, the 60 Newton vector, and we're going to draw it up here. And that vector right there, 60 newtons, is the same vector as the one that you see down below, but we have to put tail to tip. Okay, and just to help us figure out angle measures, we're going to do a little guideline right there. That's just a dotted line, horizontal, parallel to the x-axis, that helps us to see that this angle here is the same angle right here. This angle right here is the same angle as the one below. That's a 40-degree angle. Okay, whereas this angle right here is the same angle as the one you see down below as well. It's 50 degrees. So the 50-degree angles are alternate interior angles, and the 40-degree angles are the corresponding angles based on what you guys learned in geometry. So we can see that this is actually a 90-degree angle, so it actually makes it a little bit easier to do what we need to do. And let me get a green line here. Let's use the green line to represent, let's see if I can draw a straight one here. Let me make it a little bit smaller. But if we take this green line and draw it like that, oops, then let me do this one more thing here. So put an arrow at the end of it. Alright, so the green vector there represents our situation here, meaning that this is our resultant vector. Okay, so this vector here is the resultant vector. It's the result of these two forces acting upon the same object. Well, in this situation, I'm going to cheat a little bit here, and we're going to use the fact that this is a 90-degree angle. And to find the value for x, we see that x squared is equal to 60 squared plus 40 squared. Okay, and so therefore x is equal to the square root of 60 squared plus 40 squared, and that is equal to, let me use my calculator here, and I get 72.111, and I'm going to store that in alpha A. Okay? So this is the neat thing about this iPad. I realized I made a mistake, and I just changed it. You may have already noticed that. I did 60 squared plus 40 squared, but I meant to say 60 squared plus 70 squared. And what kind of made me even think that I was wrong was, or that I'd made a mistake, was that I thought 72, that seems like an awful small length for that resultant vector, and in fact it was. So anyway, I fixed my mistake. Hopefully you caught it before I had to tell you that I made a mistake. But anyway, the length of the resultant vector should be 92.195. And then again, we're going to use the fact that this is a right triangle here. The two vectors form a right triangle, and so we can use the tangent, the SOHCAHTOA. And again, I labeled this angle right in here, labeled that angle right there, theta. Okay, and so tangent of theta equals the opposite. Equals the opposite over the adjacent, and the opposite side is 60, has length 60, and the adjacent leg has length 70. And therefore theta is equal to about, well, it's equal to the inverse tangent. I should just do inverse tangent of 60 over 70, and I'll pause it here and get that back to you. So we get that theta is equal to 40.601 40.601 degrees. Now what are we going to do with that information? Okay, since theta is 40.601, if we add that to the 50, then we see that it goes just past, so 50 plus 40.601 means that we get 90.601 degrees. And the only reason I'm doing that is to see just how far, let me do this in red, how far it is from here to here, okay, in terms of, so in other words, the horizontal axis to the resultant vector from the other side, that's 90.601. Now if I were to take that 180 and subtract the 90.601, I'm going to get 89.399 degrees. And so we could say, therefore, let's do that. We'll say, therefore, the direction is, we would say 89.399 degrees. And now if we say that, it'll be, oops, what happened? What just happened? Oh, I think I hit the wrong button. 89.399 degrees would be the direction of the resultant vector, and we already have its length, and so let me put a big box around the length right there, and then we also have a box around the direction. Okay, now you could have said north, 0.601 degrees east. You could have done that also. Also, this would have been okay. All right, so there you go.